Hi everyone, welcome back to another continuous time problem, and today we are going to be solving for problem set 8.1, where we are given our linear constant coefficient difference equation right here, and then we are also given our x of t, our input. So for our goal, we're mainly going to be doing some transformations, where for part A, we're going to be trying to find the Laplace transform of our input. For B, we're going to find our system function, its Laplace transform, which is just h of s. And then for C and D, we're going to be going back and forth with our inverse Laplace transform and our regular Laplace transform of our output. So let's get straight into it. We are going to be using our game plan. For part A, we're really going to be just doing using our table to using our transformation to solve for our output. For B, we're going to be solving for h of s, and since we know that h of s is just y sub s over x of s, we can be able to find our system function. From then on, we can manipulate this equation to be able to solve for our y sub s. In the same way that we solve for our Fourier transform for our input, we can find the inverse Fourier transform of our output to be able to find y sub t. So let's get straight into it. Just like our game plan says, we're going to be using our transformation to solve for the Laplace transform of x of s, and then to be able to find our region of convergence. So there is that. For the system function, all we're going to be doing is we have our differential equation, and all we're going to be doing is solving for h of s, which I have done right here, where we take out our y sub s, so that way we have s to s squared plus 3s plus 2, and then we have our x of s on this side, onto the right side. And all we're going to do is just divide x of s on each side and just switch this over, so that way we can have our system function. For part C, this is when it gets a little bit tricky, where we are going to be doing our partial fractions. Since we now have our Laplace transform for our for our input, and we have our system function, we can then use our partial fractions to be able to solve for our Laplace transform for the output, where we're going to be solving for the a values and solving for the b values, which we have right here. And then from then on, we can then find the inverse Fourier transform to find our output y sub t. And it's just that easy. Well, thank you, and come again.